Hey everyone, it's your Sally Coach, and today we'll be doing part A, statement of the problem of experimental design. So this is going to be episode 2, and if you haven't already watched episode 1, I'd like you to watch that one so that you're up to speed. So let's get started. Alright, so before we get to the statement of the problem, let's first go over our example experiment. So our materials are 5 stock papers, 5 construction papers, 5 cardstock papers, 5 notebook papers, paper clips, glue sticks, tape, and if you bring these, a calculator, measurement device, and stopwatch. They will never ever give you a calculator or a measurement device or a stopwatch. They may give you a calculator, but that's also like you may need to rely on the other people in the room with you, so we're not too sure about that, alright? So make sure you bring calculator, measurement device, and stopwatch. Now let's look at our topic. Our topic is aviation. So going back to episode 1, I was telling you that you may need to research a little bit more on science terminology, such as aviation, buoyancy, stuff like that. If you don't already know these words, this could be pretty difficult to figure out when you get there. So aviation is pretty much aerodynamics, so let's see what it says. You will construct an experiment that researches the factors that let a plane fly the fastest. Research the different factors connected to a plane's travel distance and speed. So it gives us two main objectives. It asks for fastest and distance and speed. So distance and speed, that's mostly reliant on our stopwatch, and then fastest is mostly reliant on also our stopwatch. So, and for distance, we do have a measurement device to figure that out, but we will be using our stopwatch as a majority of this experiment. So knowing this, we're going to make sure that when we do create an experiment for this, we need to think about how we're going to be implementing our stopwatch and measurement device into this experiment. So let's go on to our statement of the problem. So how do we complete a statement of the problem? We need to make sure that this isn't just a simple yes or no question, and it should be an independent to dependent question. When I say it should be an independent to dependent question, this means that we need to have some type of relationship shown. We need to say like, oh, this is how the independent variable differs or changes due to the dependent variable, something like that. Now, we will go over what independent and dependent means later in the video, if you, not in this video, but in other videos if you don't already know, and we will be going over more terminology as we go through. But, so our sample sentence for this, right, that's going to be, how does the independent variable affect the dependent variable of the subject when the subject is something? That verb agreement is like an action. So now we're going to be forming a lot of actions, right? This is an experiment. So if we're talking about like buoyancy, right? We may say, oh, this is how the independent variable affects the dependent variable of the ball when the ball is being sunk, something like that, right? So that's the verb agreement we have in here. So our independent variable, right? How does the independent variable, so in our experiment, we will be changing our paper. Going back to this, we need to figure out how we're going to let the two different planes fly, how different planes go, and how fast they are, the distance they go, right? So we will be changing the paper airplane, therefore we're going to be changing the paper. So how does the weight and texture of the plane, right, of the paper, of the plane, all of that, so the weight and texture affect the dependent variable, which is what we are measuring, right? So how does the weight and texture affect the distance and speed of what's the subject here? What are we looking at? What are we doing to the experiment, right? Of the plane, when the plane is what? What are we doing to the plane? We are throwing the plane, so we can say when the plane is being thrown. So that's going to be the statement of the problem, and now we're going to go next to the hypothesis in our next video. So thank you for listening.